Hey class, welcome back. We're going to continue chapter 6 today, talking about molar mass, which is section 6.3 in your textbook. So molar mass is the mass in grams of a substance that is numerically equivalent to the formula mass of a substance. So if you can calculate formula mass, which we covered in section 6.1, you can always calculate molar mass because they're the same number. The only thing that's different is the units change. So molar mass and formula mass are equivalent, just the units are different. So let's say we calculate the formula mass of methane, CH4. We have the the atomic mass of carbon, 12.01 AMUs times 1 atom of carbon, plus the mass of those 4 hydrogen atoms, 1.01 AMU times 4 atoms of hydrogen. You add them up and you get 16.05 AMUs for the formula mass of methane. The molar mass of methane is the same number, 16.05. The difference is the units have changed, because when we're talking about molar mass, what we're talking about is how much 1 mole of that substance weighs in grams. So we say that there's 16.05 grams of methane per every mole, or written out as a conversion factor. It's that 16.05 grams of methane equals 1 mole of methane. And we can do this because our atomic mass units and moles of substance are both based on carbon-12 as the reference point. So because moles and atomic mass units are both based on carbon-12 as the reference point, we can take the atomic mass number and just convert it into grams per mole, because they're both based on the same reference point. So again, to calculate molar mass, first find out the formula mass and then change the units to grams of substance per 1 mole. So this is saying that 1 mole of methane, which is, we know, 6.022 times 10 to the 23rd CH4 molecules. 6.022 times 10 to the 23rd molecules of methane, which is 1 mole of methane, weighs 16.05 grams. So we're going to be using molar mass as one of the main conversion factors when we're doing chemical calculations, because the molar mass now gives us a way to convert between the grams of substance and the moles of substance. And we use this one a lot because when you're in a lab working, when you're measuring out how much stuff you have, you're not counting individual atoms or individual molecules. Instead, you're weighing out the substance on a balance, writing down the mass, and then we're going to be using the molar mass to convert that to moles of that substance. And then once we're in units of moles, if we wanted to, we could use Avogadro's number to calculate exactly how many atoms or exactly how many molecules we had. So molar mass is one that we use a lot in this class. So we're going to do some examples to make sure you feel comfortable with that. So the molar mass says that for X grams of substance, it's going to, of course, vary by substance because each substance is going to have its own molar mass. So per X grams of substance, that's equal to 1 mole of substance. Or more commonly, we write it as X grams of substance per mole. So let's say we're dealing with the element nitrogen. Nitrogen, if we round it to 2 decimal points, its atomic mass is 14 AMUs. That means its molar mass is 14 grams per mole, which another way to write that is 14 grams of nitrogen equals 1 mole of nitrogen. And so because molar masses can be written as these conversion factors, as a way to go between the mass of substance and the moles of substance, we could write that conversion factor as 2 different ratios. We could put the grams of substance per 1 mole, or we could say per 1 mole of substance, there's X number of grams. And when you're doing problems, you're going to be using dimensional analysis, and we're going to pick the ratio that works best to cancel out the unit we want to get rid of and be left with the unit we're trying to solve for. Okay, so let's do this one. I give you the final answer down below so you can kind of work through it on your own. Quickly pause the video and then check your answer, but I'll go through it as well. So calculate the moles of carbon in a 0.58 gram pure diamond. So we're given 0.58 grams of diamond, which we're going to assume is just 100% carbon. We've got a really nice diamond here. And we want to find the moles of carbon. So we're going to use the molar mass of carbon to convert from grams to moles of carbon. So anytime you're converting from grams to moles or moles to grams, you're going to be using the molar mass as your conversion factor. So our plan looks something like this. We're starting with grams of carbon, and we want to get to moles of carbon. And so our conversion factor is going to be the molar mass set up so that the grams part of the molar mass is on the bottom and the moles is on top, because we want to get rid of these grams and just have moles left is what we want to find. So again, molar mass of carbon says that 1 mole of carbon equals 12.01 grams. And we got that from the formula mass, or the atomic mass for carbon. Atomic mass, since it's just one element, it's not a compound. So the atomic mass of carbon is 12.01 AMUs, which is also its molar mass. And again, this could be written as two different ratios. We could say 1 mole per 12.01 grams, or there's 12.01 grams of carbon per 1 mole. And so we pick the one that's going to cancel out what we want to cancel and leave us with what we want to solve for, which is the one on the left. So then when we set this up, 0.58 grams of carbon times 1 mole divided by 12.01, you can see our grams of carbon cancels out, and you get 4.8 times 10 to the negative 2 moles of carbon. And we rounded that to 2 sig figs because we had 2 sig figs in our given. We had 4 sig figs in our molar mass. So the final answer will have 2 sig figs. Okay, let's do another one. So given 5.69 moles of water, calculate the grams of water. So our given is the moles of water, 5.69 moles of H2O, and we want to find grams of H2O. So our plan is to go from moles H2O to grams of H2O. And anytime you're converting from moles to grams or grams to moles, either way, you're going to be using the molar mass to do that. So let's calculate our molar mass of water. So we have hydrogen. Its mass is 1.01 AMU, and we have 2 of those, equals 2.02. We have oxygen. Its atomic mass is 16 AMUs. We have 1 of those. So when we add these up, we get 18.02 AMUs. And this is the formula mass. So the atomic mass, the molar mass is the same number, but in units of grams per mole. So 18.02 grams per 1 mole. So now we've got our molar mass, 18.02 grams per mole. And we want to set this ratio up so that moles cancel out. So we want moles in the denominator, and we want grams in the numerator, so it's what we're solving for. So 18.02 grams per 1 mole. So to solve this, let's do 5.69 moles of H2O times our molar mass conversion factor, 18.02 grams of H2O for every 1 mole of H2O. Let's get rid of this. So I'm going to do 5.69 times 18.02 to get 102. 102.5338 grams, but I'm not quite done. I've got to check my sig figs. So I've got 3 sig figs in my starting moles of water. I have 4 sig figs in my molar mass. So my final answer should be rounded to 3 sig figs. So I'm going to look to the right, it's a 5. So my final answer is going to be 103 grams of H2O. Okay, let's do another one. So how many formula units of calcium chloride are in 50.75 grams of calcium chloride? So if we lay out our problem, we're given 50.75 grams of calcium chloride, and we want to find number of formula units. So this is a problem where we're not going to be able to just do a one-step conversion. We're starting from grams and we want to get all the way to number of formula units. And we know that when we're dealing with like number of units, we're going to have to be using Avogadro's number to get there, but we're starting with grams. And so what our plan is going to be is to go from grams of calcium chloride to moles of calcium chloride. And then for moles, we can then get it to number of units using Avogadro's number. And to go from grams to moles, we're going to use the molar mass. So for calcium chloride, the molar mass is the mass of calcium, so 40.08 plus 2 chlorides, 35.45 times 2. And I get 110.98. So I'll be using that when I convert using the molar mass. I'm going to set this ratio up so that grams cancels out and I'm left with moles. So the 110.98 grams is going to go on the bottom of my conversion factor and moles is going to go on top. And then for Avogadro's number, we want to convert then from moles to number of units. So we're going to have the moles part of Avogadro's number on the bottom of our conversion factor and the number of formula units on the top. So for Avogadro's number, we're going to be using 6.022 times 10 to the 23rd units of calcium chloride for every 1 mole of calcium chloride. And so, as I previously mentioned, moles are central to doing these chemical calculations. We've kind of got to go through moles to get to anything else. And so a good hint, if you get kind of stuck on a problem and you're just like, you're panicking, you don't know what to do, list out your givens, list out what you want to find. And even if you don't immediately see the path to get from one to the other, figure out how to convert your given into moles, because eventually everything is going to have to go through moles to be converted into something else. Okay, so let's solve this out. So we've got 50.75 grams of calcium chloride We're going to set up our molar mass so that the grams cancels out. So 110.98 grams of calcium chloride for every 1 mole of calcium chloride. It's our first conversion factor. And now we're going to go on to our second one. We're going to use Avogadro's number to convert from moles of calcium chloride to number of calcium chloride formula units. So for every 1 mole of calcium chloride, we have 6.022 times 10 to the 23rd formula units. And if we check our dimensional analysis before we go on, because if we made a mistake here, we want to catch it before we take the time to plug it into our calculator. So grams of calcium chloride and grams of calcium chloride cancel. Moles of calcium chloride and moles of calcium chloride cancel, and we're just going to be left with number of formula units, which is what we wanted to solve for. So I'm going to plug this in, 50.75 times 6.022 times 10 to the 23rd, and then I'll divide that by 110.98 to give me an unrounded answer of 2.753 and on times 10 to the 23rd. But we always have to check those sig figs. So here we have 4 sig figs, 5 sig figs, 4 sig figs. So we're going to round this to 4 sig figs. Thankfully, I still have this pulled up on my calculator because I'd want to know a few more digits before I round that after that 3 comes a 7 and then it goes on. So if I'm rounding to 4 sig figs, this is going to be my last sig fig. So I end up getting 2.754 times 10 to the 23rd formula units of calcium chloride. Okay, so next we are going to continue on our next lecture with section 6.4, chemical formulas and mole conversions. Thanks for listening, and I'll catch you all next time.